Hey guys, how you doing? Welcome back to my video series on solving LeetCode problems. Right now we're solving the trapping rainwater problem, 42. And what is this about? Given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So let's look at the example. Imagine it's raining. Where does the water get trapped and doesn't slide off to the edges? It gets trapped here, 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 here. So it's 6. The output is 6 because it's 1 block, 2 blocks, 3 blocks, 4 blocks, 5 blocks, 6 blocks. And the height is 0, 1 black block, 0 black blocks, 2 black blocks, 1 black block, 0. And this is what it represents. So I came up with a solution that works but consumes a lot of memory. Just to give you my solution that I came up with before researching it, it was let's sort these indexes here by let's visit the biggest one and then all the way to the smallest one. So we start with this 3 and 2 and we check how many blocks of water we can make between those two. Then we go from 2 and 2, which is these two. How many blocks of water can we put? Oh, we can put all of them here. And we just kind of check if there are black blocks in the middle or not. And then we would remove water that we could potentially put. And it actually works. It works for 318. Let me show you. It works for 318 out of 322 test cases. And I was pretty disappointed because I was proud of what I did, but it seems not to be good enough for LeetCode. So I was researching and I found out a new solution. So the solution is pretty simple. So let's walk from the left to the right, and let's see how many water blocks can this support on the left. Well, 1, because let's imagine to the left of this how much water could be. Well, 1. And here, how much water does the black block support here? Well, there's no black block, so it's 0. But yeah, we already have a 1 here, so let's put the 1. Oh, sorry, I did something wrong. So how many blocks of water can this support to the right? So it's actually 1, because it's 1 block of water that it can support all the way. And about this one, well, it's 0, but we already have a 1 before, so 1. About here, oh, it's 3, because now it's 3, it can support 3. And this one over here, well, it's actually 1, but we have a 3 here, so it can support 3. 2, but we have a 3, so it's this one or the maximum, this one or the previous, if the previous is bigger. And same thing. Now let's do the opposite. Let's start with I'm doing a lot of white spaces. Start with the end. How many blocks can this support to the left? Well, this can support 3 blocks. And this can support 0 blocks, but it supports 3 because of the other one that supports 3. Same thing here, 2 blocks, but it supports 3. Same thing, same thing, same thing, same thing. So it's pretty 3. And the solution is, brace yourselves, is the minimum of both of these minus the number of blocks. So let's look at how many blocks of water can we have at this position over here. We can have 2, right? Because to the left over here we know that it can support up to 3 blocks. Okay? And we know that to the right, there's a block that supports up to 3 blocks of water. And oh, cool, 3, 3. The minimum of both is actually 3. But then we subtract the number of blocks here. So 2. 3 minus 1, 1 black block, 2. Same thing here. But we have 2 black blocks. Minimum of 3 and 3 is 3. So 3 minus 2, 1. Same thing here. 3 is 3. Minus 0 is 3. Same thing. 3, 3 minus 3 black blocks, 0. And now 3, same thing. 0. Minimum 1 and 3, 1. Minus 0 black blocks, 1. And here it's minimum 1 minus 1 black block, 0. The sum is 1 plus 2, 3. So yeah, you can see 1 blue, 2, 1, 3. That's it, let's get to coding. This is a super simple approach. And this will definitely pass. So let's go left support, and we go and let's just start with height of 0. It's a list of integers that starts with height of 0. Oh, sorry. Why is this not saving? Where's the error? Oh. There it is. Sorry. Messed up. So for index in range from 1 to height, length of height. So we check potential val is equal to the height of the index comparing to the last value on left support, and remember the maximum value. Remember when we were doing in the beginning this over here, so 1, 1, this is 0 but it's the maximum of both, 3, this is 2 but it's maximum, so we do that. So we can just go left support dot append so let me just put a breakpoint and let's see what we have so far. 1, 1, 3, 3, 3, 3, 3. Yeah, same. 1, 1, 3, 3, 3, 3, 3. Now let's do the same for right support. And right support is the list of integers. Now we start with the last element. For index in range, well, now it's different. It's length of height minus 2 because we want to start from the second last element all the way to 0 inclusively, so it's minus 1, the limit, and the step is minus 1. So we're iterating backwards the indexes. So right support equals the max of I index and right support 0. Actually, no, let's do minus 1, and then at the end we just reverse right support. So let's look. So left support, yeah, 1 1 free free free. Right support, free 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 free. It's all freeze. It's all freeze. Let me just change this to a 2 to see if it would be free free 2 2 2 2 2. Support free 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 2 2. Yeah, good. So it's working. So now what do we do is final val is an integer that starts with 0. So this is the water that we're accumulating. So we for index in range length of, well, height or left support, right support, doesn't matter. They all have the same length. And what do we do is the final value plus or equals the minimum of left support I, right support I, left support I, right support of I, minus the number of black blocks, which is height of I. And sorry, not I, index. And then at the end return final value. Let's see if it passes all the cases now. It does. Oh well guys, I hope you enjoyed it. See you later.